Hi guys, welcome to a new video. Today we are going to start a lecture on kinematics, or you can easily say motion and time. So this lecture is going to be very interesting. So please like and subscribe this video and share as much as possible. Before studying kinematics, we need to know what kinematic is. So, kinematics is the branch of mechanics which deals with the motion of bodies without considering the cause of motion. So, kinematics basically comes under the branch of mechanics, and we all know that mechanics has two branches, statics and dynamics, and this kinematics comes under dynamics. Means in dynamics we are going to study about the motion of bodies and we will not be concerned about the cause of motion, which means we will not be concerned about the force. So the first topic which we are going to study in this chapter is vectors. You can see vectors, the quantities which rely on both magnitude and direction in order to define themselves, are known as vectors, which means that vectors need direction. Vectors need direction. That is why they are distinguished from scalars. Scalars do not need direction, they have magnitude. But vectors have both magnitude and direction. So it makes them the most suitable physical quantity to define anything in mechanics. And that is why the study of vectors in this chapter is going to be so important. In vector notation, we denote any symbol with an arrow which indicates that it is a vector. For example, if I write force in vector notation, it would be written as like this. You can see. You can see the arrow above the symbol of force. In the similar way, we can denote acceleration by writing small a and then a vector. And the length of this line can also denote the magnitude of the vector, as it denotes the direction of the vector. For example, if we project a projectile here, so its tendency will be to move towards this direction. But under the influence of gravity G, it will be pulled downwards, and with time it will go downwards and follow this type of trajectory. So here this arrowhead defines the velocity of the projectile, and as you can see in this example, this arrowhead defines the direction of the vector and the acceleration g. You can see it's defined by this arrowhead because its direction is downwards. It influences everything which comes under it. Now from this example only we can study about distance and displacement. So we need to focus on this horizontal x-axis. Okay. So if I ask you that what is the distance covered by this projectile, so many of you will simply say that this path which I am drawing is the distance. Of course, you all are correct. From if I mark this point as A and this as B, then the distance ACB will be the distance covered by the projectile. But what do you mean by displacement? Now, first thing which you know about this, which you need to know about displacement, that it is a vector. Okay. Distance depends upon the path, but displacement does not depend upon the path. Displacement can be on any path, such as if I draw a curved path. I mark 2 points as A1 and A2. The shortest distance which means a straight line from here, will be the displacement S. Okay, so we denote displacement as S and an arrowhead, of course, to denote a vector. So the distance covered by the projectile will be ACB, but the displacement will be only AB. This path. AB or BA, anything you can say, is the displacement. Now, as we are studying 2D kinematics, the displacement is always a straight line. Displacement is always a straight line. Okay. But in 3D, displacement is always not a straight line. It is a curved line. And you will understand this when we will upload a lecture on kinematics 3D. Now, we are going to study about position. Now, what is position? To understand this, we will take an example. So, we are taking a ball here on this horizontal x-axis on this path, and we are supposing it to be here. So, the position vector, a position vector P, defines the position of any particle or any object or any matter from a point O to horizontal or vertical axis. So what is this position P? This position P indicates that where this ball and from how much distance it is away from the point O, which you have marked as the initial point. Now, as you all have understood distance and displacement, so in this case you can see that the distance and displacement as measured horizontally from the point O are same. So we can write this is the displacement, OP here is the displacement. We can write OP is the displacement, and we can write that OP is the distance also. And one more thing I am going to tell you, that distance can also be denoted by a symbol x. So if we are defining speed, we can write x by t or x into t to the power minus 1. Okay. So from this example only we can study about speed also. So here displacement OP or distance OP, x we can take as the distance. First we will study speed. So the speed basically means distance upon time. So speed means distance upon time, or speed is the distance covered per unit time. So if we take OP as the distance, I am taking OP as the distance. So we can calculate speed from here. So I am taking OP as the distance. So the speed will be distance, which is OP by the time taken. The time taken by this ball to reach from the point O to the point P will be the speed. So here in this case I am taking x to be 5 meter and the time to be 5 seconds. Okay. So now from here we can see that the speed of the body is going to be 5 meter, which is the total distance, by 5 seconds. So 5 and 5 will cancel from here. So you can see that it's 1 meter per second. So one thing we should always know, that the SI unit of speed is meters per second. Meters per second is the SI unit of speed. So anything if it is given in kilometer per hour, suppose it is given in kilometer per hour, if I say that a bus is moving with 18 kilometer per hour, so you can just say that you will have to convert it to meters per second. So what you will have to do is to multiply it by 5 by 18. We are multiplying it by 5 by 18. So the speed comes 5 meters per second. So we can say that 18 kilometer per hour equals 5 meters per second. So by this shortcut trick, we can convert anything which is given in kilometer per hour to meters per second. And this thing is going to help you a lot in numericals. Now the next topic which we are going to study is acceleration. Now to study acceleration, we are taking a simple example. We are taking a ball here, and we are throwing it with a velocity v. So its tendency will be to move in this direction, but it will be influenced under gravity. So its motion would be like this. This would be a trajectory. So can we say that its velocity will be changed? Its velocity would not be the same as we are throwing it with, suppose that 5 meter per second velocity. So the velocity on it can be 10 meter per second because of the influence of gravity. It would be 10 meters per second under the influence of gravity. So this change of velocity, this change of velocity with respect to time is known as acceleration. Simply acceleration. So acceleration is defined as rate of change of velocity, which means that final velocity minus initial velocity. We can write it as final velocity minus initial velocity by final time minus initial time. So from here we can say that the rate of change of velocity over time. So we can say that acceleration equals delta v by delta t, or simply delta v by t, as you can see. So suppose that this velocity is changing in 2 seconds. Okay. So we have taken that the velocity is changing in 2 seconds. So we can say that the acceleration will be final velocity minus initial velocity by time taken. So what is the time taken to change it? Meters, 2 seconds. So it becomes 10 minus 5 by 2, and meters per second. It means that meter by second, and this second will remain here only. So it will become 5 meters by 2 second, and second will multiply to become square 5. So it will becomes 5 by 2, we can change into a fraction 2.5. 5 by 2 we can change into fraction 2.5, and this meter per second square can be denoted as meter into second to the power minus 2. Am I correct? Yeah. So this is the acceleration of this body when thrown from the point A to point C. Now there is a simple question for you all. As I have told you the meaning of distance, displacement, speed, velocity and acceleration, these were the basic concepts in kinematics, and these concepts will help us greatly in these numericals of this chapter. So suppose an object is moving from this path A to this point B, okay, and it started from here and it again moved from there from point B to point A. So, can you tell me the displacement? You can take as time as you can take. Most of you will say that the displacement will be the length of this path plus the length of this path. But some of you will tell that the displacement will be 0, because displacement means the change in position, and this body had moved from here, then it again moved to here only. So what's the change in position? It started from the same place and it again moved back to the same place. So the displacement will be 0. So this was a bit confusing question, but it helped us to build great concepts. So now we are going to study about the 3 equations of motion which will help us in our numericals of this chapter. Now these equations of motion were given by Newton, and these equations of motion are applicable to a body moving with uniform acceleration. So the first equation of motion is V, which means velocity, equals u plus at, which means that velocity v, you understand here the meaning of these terms. Here v is the final velocity. U is the initial velocity, and A is the acceleration, and T is the time. Okay, T is the time. So I can tell you that this equation was simply derived from this equation. We know that if we take final velocity as Vf in acceleration, we know that acceleration equals final velocity minus initial velocity by time. So we are taking final velocity as what? We are taking final velocity as v. So v minus initial velocity u by t. A equals v minus u by t. So v minus u equals at. Then we can say that v equals u plus at. So this first equation of motion was simply derived from this equation. And this equation helps us greatly in our problems, and it also helps us to save calculation. Now moving on to the second equation of motion. The second equation of motion is S, displacement, equals ut plus half at square, which means that displacement equals initial velocity into time plus half of acceleration into time square. So if you want to derive the unit of this, what will the unit? Unit will be that acceleration unit is meters per second square into time square, time into time square. So this particular part of the equation's unit will be meters. We have derived the unit, and this unit ut, u is velocity, so meters per second, and t, time is in second, meters. And we can say that this equation is dimensionally homogeneous because the unit of displacement is meters, this unit is meters, and this is also meters. So by the vector law of addition we can say that this is dimensionally homogeneous. Okay, from here the mass is nothing but time is there, mt to the power 1 m1t1 plus time cancels out by t, m again, m1 t to the power 2, and it cancels out, so meters, and this is also meters, and we can say this is dimensionally homogeneous. Now the third equation of motion states that v square equals u square plus 2as, means velocity, the final velocity, the square of the final velocity equals the square of the initial velocity plus 2 into acceleration into the displacement. So these were the three equations of motion, and these equations will help us greatly in our numericals. Now let's move on to the graphical representation of motion. Displacement time graph. First, in this graphical representation of motion, we are going to study about the displacement time graph. Okay, so suppose we are given a chart that about a body's displacement covered in different periods of time. Suppose that it's given as in 0 second it has covered 0, in 1 second 2, so this is the data given. So on this graph we can represent it. So from this data we can see that it is in uniform velocity, because we see that in each second, in each unit second, it is covering 2 meters. So we can say that the velocity is 2 meters per second. The velocity is 2 meters per second. Now for graphically representing this on this graph, we need to first locate the points. So now we have located the points. This is 0 second, 1, 2, 3, 4 and 5, and from this we can mark as 2, 4, 6, 8 and 10. Now we can locate the points as this, again matching it with the second, then again sixth with the third, and from this continues entirely, and now we can see that it is a straight line. We can clearly see that it is a straight line. So now here we will study about a very important thing in this chapter, which is slope of a graph. What does slope mean? Slope basically, if we talk mathematically, slope means measurement on y-axis by measurement on x-axis, or we can say it by many different things, such as first thing, or we also say that uh, rise by run. We also say it like that. Or if we talk a bit about calculus, we can say that it's dy by dx, or the rate of change of y with respect to the rate of change of x, means delta y by delta x. So here in this graph, what is the rate of change of y? As you know, this is y, this is y axis, this is x axis. So what is the rate of change of y? 2, 4, 6, 8. The rate of change of y is 2. What is the rate of change of x? 1, 2, 3, 4, 5. So it's 1. So the slope is 1. Now we have found here a common thing, that the velocity is also 2 and slope is also 2. So from here we conclude that the slope of a displacement time graph gives us velocity. So friends, this is all for today, and in the next lecture we will continue with slope. We will complete it, and then we will also start with the numericals of this chapter. Please like and subscribe to my channel and share as much as possible. Please. Thank you for watching my video.